Hey, Dave Stoblin here, and we are going to do some trig identities. Now, before we do that, I want to go back to our unit circle where we had a center and then we had a circle going around here, and every coordinate or every location on the unit circle had an XY coordinate, and you could make a little triangle basically with the radius of 1, and the coordinate would be x and y. And one of the things that we showed was that cosine of the angle is adjacent over hypotenuse, x over 1 is x. And sine is opposite over hypotenuse, y over 1, which is y. And tangent is opposite over adjacent, which is y over x. And we know y is sine and x is cosine, so tangent is sine over cosine. And similarly, we have the inverse trig functions, secant, cosecant, and cotangent, and here they are right here. So I want to do two things with you. The first is Pythagorean Theorem for this triangle. Well, we know that the two legs, like x squared plus y squared, equals the hypotenuse squared. Well, here's what we can do. X is the same as cosine. And so we can write cosine squared of the angle plus y squared, and we know y is sine. Sine squared of the angle equals 1 squared, which is 1. And there is a brand new trig identity. Now, I just want to make sure that you understand that cosine squared theta is different than cosine theta squared. And this is very important because this means cosine squared means cosine theta. It means there are two cosines, whereas this would mean that you have cosine of theta times theta, like that. So you have to be very careful on the placement of your exponent. All right, so let's do a more complicated problem, and here it is. Let's say that we have the tangent of an angle times the sine of an angle plus the cosine of an angle, and it says equal to secant of an angle. So what we want to do is we want to prove that this is true. Okay, we want to prove that this statement is true. Now here's how we're going to do it. What I recommend is that you try to turn everything into sines and cosines. So, for example, this tangent we know is the same as sine over cosine. And then we have times the sine plus the cosine, and we want to show that that's true. Now, let's see what happens. We end up with sine squared, right? Sine times sine over cosine plus, and now we have this cosine right here. Now, technically, this is just cosine theta over 1. But if we wanted to actually add these together, we would need to have a common denominator. And how could we get that common denominator? Well, we could multiply top and bottom by cosine of theta, and then this fraction turns into cosine squared of theta over cosine theta, and over here we got sine squared of theta over cosine theta. And now we're getting something interesting, okay? So let's rewrite this. We have a common denominator, so let's rewrite this as cosine theta, and then up here we got sine squared plus cosine squared. And guess what? Now the exciting part is going to happen. What's sine squared plus cosine squared? Right here, sine squared plus cosine squared is equal to 1. So this is the same as 1 over cosine of theta. And we wanted to prove that it was secant theta. And what is the definition of secant? 1 over cosine. So we just showed that our original statement here is true. Isn't that cool? Hey, there's 3 more problems on the worksheet. See if you can do them on your own before you break down and look at the answer key. These are challenge problems, so they're not meant to be easy, but I know that you can do them.